Alright, here are the targets 6 through 8 notes for Unit 6. We just took our quiz and we're kind of getting into the second half of the unit now. We're going to start off with simplifying and multiplying rational functions using a lot of factoring today. So lots and lots of factoring we're going to be using today. Mostly just factoring out the GCF, and then sometimes we'll have to use our AC method factoring where we find out what factors of our C term is going to add up to be our B term, just like we've seen before. We have been, doing that on our algebra, I'm sorry, our factoring quizzes and everything like that. So we're going to incorporate that in today's lesson. So the first few problems, it says simplify the following rational expressions here. So to get started with today's lesson, you need to know that we're going to be doing a lot of canceling as well. So when I say canceling, I mean, like, for example, in A, 20 divided by 4 would reduce to 5 over 1. So I'm going to reduce that to 5 over 1. I know it's kind of small here, but 20 would reduce to 5, and my 4 would reduce to 1, because 20 divided by 4 is 5. And then over here, my x squared over x to the 4th, how can I reduce that? Well, think about it like this. I technically have 2 x's on the top and 4 x's on the bottom, so it looks something like this. X times x on the top, and then x times x times x times x on the bottom. So 2 on the top, 4 on the bottom. Can I cancel anything on the top and the bottom? So like 1x on the top will cancel with 1x on the bottom, like this. I can actually do that twice here. What I'm left with is 2 x's on the bottom, and we represent that with x squared. Okay, so going back to my problem, everything kind of canceled out nicely. And what do I have left? Well, on the top, 2 of my x's canceled, so I only have that 5. And then on the bottom, I don't have any numbers besides 1, but then I have that x squared that I figured out was left over here. So 5 over x squared would be that answer. Okay, let's go to B. The only way you're going to get good at this is if you practice, practice, practice. So let's look at B. 3x plus 3 on the top and then 6x on the bottom. The biggest thing today, like I said, factoring. So we're going to want to factor and then cancel every time we see a problem today. Factor everything and then cancel. All right, well, on the top, I have that 3x plus 3. I'm going to have to pull out a 3 as a GCF, and then I'll be left with x plus 1. So I'm just using my GCF factoring here. I'm actually going to turn this into 3 times x plus 1. So I just pulled a 3 out. On the bottom, I have 6x left over. And something else very, very important today is in the beginning, let's say you saw this problem here and you thought, oh, well, 3 over 6 reduces to 1/2. You cannot do that, and I will tell you why. You cannot do that because you can only cancel things that are being multiplied together. Okay, multiplication is the biggest thing about today. Because we have this plus sign on top, you cannot take this 3 and take it away from that numerator because it's being held together with it's being held together with addition. Think of addition and subtraction as marriage. It is the tightest bond that 2 terms can have. They are bonded for life and you can't separate them. So we can't take away that 3x or that 3 from the top and cancel it with the bottom. We have to actually move on to factoring. And if you realize this, we actually took a GCF out from the top, and now it's 3 times x plus 1. Now that we have everything separated by multiplication, multiplication is a little bit weaker. It's not as strong as addition. So now that we have multiplication on the top, I can cancel this 3 with that 6 and reduce it to 1 over 2. Now I can do that. So now what I'm left with is x plus 1 on the top, and I'm left with 2x on the bottom. Once again, you cannot cancel these 2 x's here. Please do not try and cross those out because they are being held together It's being held together by addition on the top. You can't take that x away from that 1. They're married. They have the tightest bond possible. You cannot take them away. So we have to leave our answer just like this. Unless we could factor further, which we can't, then we could cancel more, but we cannot. All right, let's go down to C. Factor everything and then cancel. So I'm going to factor the top. I have x squared plus 5x plus 4, so what times what will give me 4, and what plus what will give me 5? 4 and 1. Yeah, so I have x plus 4 on the top times x plus 1. And then on the bottom, I'm just factoring out a GCF here because it's only 2 terms. I'm going to factor out a 2, and I'll be left with x plus 4. Okay. This lesson is actually kind of fun because once you get everything factored, a lot of things will cancel here, which is kind of cool. So like x plus 4 and x plus 4 can cancel. They are 2 separate things. They're being held together by multiplication on the top and the bottom. And the reason I can cancel those is because x plus 4 is one thing. X plus 1 is another thing. 2 is another thing, and x plus 4 on the bottom is another thing. So it's not like I'm taking the x away from the x plus 4. I'm taking it away from the x plus 1, which it's being multiplied to. That's where I can cancel that. So on the top, all I'm left with is x plus 1, and on the bottom, I'm left with 2. That's as far as I can go. All right, on D, I'm going to factor everything. So on the top, I'm just going to factor out a GCF of 6. I'll be left with x plus 2. On the bottom, factoring out a 2, also left with x plus 2. So if you notice here, we're going to be able to cancel x plus 2 with x plus 2. We call those factors. Terms that are being multiplied together are factors. So then 6 over 2 will also reduce to 3 over 1. So we really just have 3 over 1 left over, which you can just write as 3. If you leave it as 3 over 1, that's okay too. So we're just left with 3. All right, and that is simplifying. Let's move on to multiplication, which is another form of simplifying. It's just a little bit different because we're just going to combine everything on the top and then everything on the bottom. So basically, the rule here is we're going to, and I'll write this kind of up here, we're going to factor everything cancel what we can, and then combine on top and bottom. So the numerators will combine and then the denominators will combine. Another good thing to note is that we can only cancel things up and down or diagonally. We cannot cancel left and right. So I'll give you an example. Quick example. Let's see. I can say that 1 over 2 times 2 over 3 is actually 1/3 because I'm canceling diagonally here, and 1/3 would be the answer. Obviously, we know we can cancel up and down. Something we cannot do is say, okay, well, 2 over 3 times 2 over 5, well, will these 2's cancel? No, we cannot do that because we can only cancel up and down or diagonally. Only up and down or diagonally. All right. Let's get back to our problems. So let's look at A first. Now, on A, there's actually nothing to factor out. We just have things being multiplied together. But what I am going to do to make it easier on me to cancel, and you can cancel however you want. If you want to just say that 14 over 21 is 2 over 3 because you can divide those by 7, go ahead. I'm going to take all of these numbers, all 4 of these numbers, and I'm going to break them down into like the smallest numbers that I can. Does that make sense? I'll show you what I mean. So like 14, I'm going to say 14 is 7 times 2. then I have my x squared on the top. And then my 15x, I'm going to say 15 is 5 times 3, and then I have that x on the top as well. And then on the bottom, I'm going to say that 8 is 4 times 2, then I have x cubed. And then I'll say that 21 is 7 times 3, and then I have x to the 4th. I'm going to do this in steps. All right, so do we see any numbers that are going to cancel up and down right here? Well, now that we've combined everything, everything is on the top or on the bottom. We don't have any diagonals anymore because I just went left to right and combined everything. That's what you do with multiplication. So like if you have 1 over 2 times 3 over 4, how you multiply fractions is you just say 1 times 3 is 3, 2 times 4 is 8. You just multiply straight across. I'm going to say that 7 cancels with 7. That'll work. I have 2 here that'll cancel with 2, and then I also have a 3 canceling with 3. Okay, so on the top, the number I have left over is 5, but then I also have x squared times x, which will give me x cubed actually. On the bottom, I have a 4 left over, and then I have x cubed times x to the 4th, so x to the 7th is what I have left over on the bottom. But now I have to do another step. I have to cancel out those x's because I have 3 on the top and 7 on the bottom. So I'll tell you a little trick that I remembered to how to cancel things. My little trick goes like this. You take the exponents, 3 and 7, and you find the difference between those two numbers. So I'll do 7 minus 3, that gives me 4. Sorry, equals 4. Okay, so I know I'm going to have x to the 4th somewhere. And am I going to put it on the top or the bottom? Well, I'm going to put it wherever the largest exponent was. So in this case, I'm putting it on the bottom with that 4. So my answer is 5 over 4x to the 4th. So once again, I'll show you what I mean by the little trick. I take this answer and I say, well, I still have x's on the top and the bottom. I have to cancel something. I take the exponents that I was working with, 3 and 7. I find the difference between those two numbers, so I can just do 7 minus 3. If you can do that in your head, that's even better. So I got 4, which means I'm going to have x to the 4th either on the top or the bottom. So 4 just turned into my new exponent. And then I say, well, is it going to go on the top or the bottom? Well, it's actually going to go wherever my original largest exponent was. So because 7 was bigger than 3, I'm going to put that x to the 4th on the bottom. So it's going to go on the bottom. And I'll practice that more once we get through more of these, but let's go to the next one. Let's see. I got a lot of factor here. Got a lot to factor. So I'm going to factor the first one. I'm going to factor a GCF out of the top there. So I have 3x times x plus 5. And then I have times 2 over there at the end. I'm just combining everything on the top with everything on the bottom, multiplying straight across. On the bottom, I have x squared times, I'm going to take a 2 out of 2x plus 10. I'll be left with x plus 5. All right, let's see if anything cancels here. Oh, I think a lot of things are going to cancel. X plus 5 and x plus 5, 2 and 2. And then I have x to the first power on top and x squared on the bottom. Okay, I'm going to use my little trick here. I'm going to look at the exponents that I have, and I'm going to say the difference between 2 and 1 is 1. So I know I'm going to have x to the first power somewhere, and it's actually going to go on the bottom because that's where I had my biggest exponent. 2 was bigger than 1. So my answer here is 3 over x. 3 over x. That's all that was left. All right, C. If you ever have a situation like this, like C, be mindful that any number, or like in this case 5x plus 5, so this like term here, this right there is actually over 1. So I do have that kind of like a fraction, it needs to be over 1. So, as you're going through these and you see just something without a denominator, just add 1. Okay, just put it over 1. It'll make it easier for us to combine on the top and the bottom because we know what's on the top now. So we're going to combine left to right after we factor everything. On the top, x squared is just going to be x squared. I can't factor that. But then I can factor a 5. Out of 5x plus 15, I'm left with x plus 3. And then on the bottom, this is my AC factoring. So let's see, x squared plus 3x minus 18. I'm thinking, what times what will give me negative 18? And what plus what will give me positive 3? Well, in this case, it's going to be positive 6 and negative 3. 6 minus 3 will give me 3. 6 times negative 3 will give me negative 18. So on the bottom here, I have x plus 6, minus 3. X plus 6, x minus 3. All right, let's see. Does anything cancel here? You might be thinking x plus 3 and x minus 3 will cancel, but those are not the same. They have to have every single part of them the same. So x plus 3 would cancel with x plus 3, but we have a minus sign in the denominator, so that's not going to work. 5 can't cancel with anything. X squared can't cancel with anything. This is actually just going to stay how it is. And at this point, you could circle that right there. I'm going to make it look a little prettier on the top. I'm going to combine my 5 times my x squared to be 5x squared times x plus 3. On the bottom, I have x plus 6, x minus 3. So unfortunately, nothing will cancel here. Sometimes you will run across that issue where nothing cancels after you factor. That's okay. If you wanted to go ahead and multiply all this through and take the time to FOIL and distribute, go ahead. But I think we're all okay with us leaving our numerator and denominator the way it is because we've already factored, so why go backwards and multiply again? There's no reason to. All right, so on D, I'm going to factor everything and then see what cancels. I can take a 2 out of 4x plus 10. I'll be left with 2x plus 5. And then I also have that times x minus 1 on the top. So kind of what I'm doing here with all of these problems, I'm factoring everything and I'm also combining the two numerators together and then the two denominators together, kind of like all in the same step. Now you can take more steps if you need to, but it's not necessary if you don't want to. Okay, let's see. And then I'm taking a 5 out of 5x minus 5. I'll be left with x minus 1. And then I'll take a 3 out of 6x plus 15. I'll be left with 2x plus 5. Ooh, this is nice. I have a lot of things that are going to cancel. 2x plus 5 with 2x plus 5. X minus 1 with x minus 1. And then 2 on the top, 15 on the bottom. That's what I have left. I got that 15 by doing 5 times 3, which were my two leftover numbers. Whenever I have actual just whole numbers left, like 5 and 3, I don't want to leave it like this, like 2 over 5 times 3. You can go ahead and multiply those two numbers together. That would make the most sense there. All right, let's go on to the back side of the notes, which is division and then complex fractions. Ooh, okay. So divide and simplify rational functions is target 7. So it says here, let A, B, and C and D, be non-zero variable expressions. To find the quotient of A over B divided by C over D, we rewrite the division as multiplication of the reciprocal. So basically all this is saying in a very fancy way is we keep, change, flip. Keep, change, flip. Keep, I don't know if you've ever seen this before, change, flip. So you're gonna, when you're dividing two fractions together, you keep the first fraction the same exact way it is, so A over B. You change the division to multiplication, and then you flip the second fraction. So before it was C over D, now it's D over C. And I'll show you what I mean by that. Let's look at A. I have 7x over 3 divided by 2x over 9. I'm going to rewrite this with my keep, change, flip. So 7x over 3 is going to stay the same. I keep that. Then I change my division to multiplication. So I change this, and then I flip my second fraction. So this becomes 9 over 2x. Okay, well that kind of makes sense. At this point, I'm not going to rewrite this with everything combined. I'm just going to start canceling things, because I can cancel diagonally for sure. 7 over 2, 7 over 3, nothing works there. My x's will cancel. And then also 9 over 3 reduces to 3 over 1. So on the top, I have 7 times 3 over 2, which we know we can write as 21 over 2. Okay, that's an example of keep, change, flip. Let's look at another one. B, we have negative x cubed over 3 divided by x squared over 6. So I'm going to keep negative x cubed over 3, change my division to multiplication, and then flip my second fraction to be 6 over x squared. Okay. Technically, negative x cubed is just negative 1 times x cubed. So the negative sign isn't going to affect much. You're just going to kind of leave it out front the whole time. 6 over 3 we know reduces to 2 over 1. And then 3 over 2, I'm going to use that little trick that I know how to do. I'm going to take the difference of these two numbers, which is 1, and I'm going to say, okay, well I know I'm going to have an x to the 1 power, or just x somewhere, and it's actually going to be left on the top this time because I have 3 is bigger than 2. So everything cancels on the bottom, and I have 1x left over with that 2 on the top. This becomes negative 2x as my answer.
Jennifer Hagney, if you're in the building, please come to the front office. Thank you.
If you notice, I had to keep that negative sign out front the whole time, and in my answer, it just got tacked on there. Just my answer, just the negative sign. All right, let's look at C. This is getting a little complex here. I'm still going to use my keep, change, flip method. So I'm going to keep this fraction the way it is, change division to multiplication, and then flip my second fraction. So I have 8x cubed minus 24x squared all over x minus 3. All right, let's see if I can factor anything now and cancel. 1 over x plus 1 is going to stay the way it is. I can factor actually an 8x squared out of the top here, and I'll be left with x minus 3. On the bottom, I literally just have x minus 3. Nothing changes with that. So let's see, my x minus 3's will cancel. That's nice. But other than that, nothing's going to cancel here. So I have to have 8x squared over x plus 1 as my answer. It's the simplest I can make it. I cannot cancel those x's because, once again, on the bottom, x is being held together with my 1 by addition, and addition is so strong. It is like the marriage of numbers. You cannot take x away from its 1. All right. Let's see, keep, change, flip again. KCF. So 1 over x plus 7 is going to stay the same. Change that to multiplication, and then I'm going to say, after I flip this, it's going to look like this. X squared plus 14x plus 48. On the bottom, I have x plus 6. Okay, let's see. Now I have to factor kind of a lot on the top using my AC method. What times what will give me 48? And then what plus what's going to give me 14? It's kind of good to write out the factors of 48 here. Just kind of give me a heads up. Let's see, I have 1 and 48, 2 and 24, 3 and 16, 4 and 12, and then I have 8 and 6, or 6 and 8. Let's see, I need all positives here, all plus signs. No, nothing. Let's see, not gonna work, not gonna work, not gonna work. No. Ooh, 8 and 6. Alright. So let's see. I have 1 over x plus 7 times, now I have x plus 8, x plus 6, all over x plus 6. All right, the x plus 6's will cancel here, which is super nice. And all I'm left with is x plus 8 over x plus 7. Do not cancel those x's at this point. If you do this and say that your answer is actually 8 over 7, that'll make us math teachers just cry. That'll make us so sad because you cannot take the x away from its 8 or its 7. It's held together by marriage. That addition is such a strong bond. So do not take those away from each other. All right, final target, target 8, we're simplifying complex fractions. And the way to do this is to kind of look at this and say, all right, what the heck is happening here? What is going on? Well, in the numerator, we have 1 over 2x. Let's look at that. We have this fraction right here. Then we have a bar, which means division. We know that. And then we have another fraction, x minus 1 over 5. So we have 1 over 2x divided by x minus 1 over 5. I'm going to rewrite this just so that you guys can see it. What I'm talking about here. I have 1 over 2x divided by x minus 1 over 5. That is the simplest way we can put it. I'm changing my complex to a division problem every time. If you notice in all 4 of these, we have a big old bar in the middle of them, which means division. So I'm going to rewrite it as a division problem so that we can treat it like we did in target 7. At this point, I'm going to use my keep, change, flip strategy once again. 1 over 2x times 5 over x minus 1. So I just used that same strategy that I was using in target 7. I keep my first fraction, change to multiplication, and then flip my second fraction. Okay. Nothing can factor, nothing can cancel. Unfortunately, this is just going to stay 5 on the top, and then on the bottom I have 2x times x minus 1. This is just about as simple as I can make it. That one didn't really cancel a lot, but it was a good example of how we do complex fractions. If you could cancel, you would cancel. All right, let's go on to B. Okay, I'm going to rewrite this as a division problem first. So I have 3x plus 7 over x minus 2 divided by 5x over x minus 2. Okay, so I have this big old division problem now. And I'm going to change this to a multiplication using my keep, change, flip strategy. 3x plus 7 over x minus 2, that will stay the same. Change it to multiplication and then flip my second fraction to be x minus 2 over 5x. Okay, now, if you notice, x minus 2 and x minus 2 are the exact same. Those will cancel. And on the top, 3x plus 7 and 5x, nothing can cancel there. Technically, this 3x plus 7 is one factor, so like they are bonded by addition. You cannot cancel those x's with the 3x and the 5x. You just have to leave that the way it is. So 3x plus 7 all over 5x is the answer. Not a lot of canceling. Okay, let's do another one. 2 more. Let's see. All right, 1 over 5x divided by x minus 3 over 5. 1 over 5x divided by x minus 3 over 5. You should always think of these complex or fraction within a fraction problems as division problems, because that is essentially what they are. All right, I'm going to change, keep, keep, flip, change. No, keep, change, flip, sorry. Keep, change, flip. Getting all mixed up here. So I'm going to keep my first fraction, change to multiplication, and then flip my second. All right, let's see. Ooh, I do have that 5 to cancel with that 5. Nothing else. That's all I can do. On the top, I'm left with 1. On the bottom, I have that x left over from my 5 here. And then I just have that times x minus 3. And you could go ahead and tell me that is x squared minus 3x if you want. Or you can literally just leave it like that. No big deal. Okay, last one. Number D. Problem D. Letter D. Whatever. Okay. 16x plus 4 all over x minus 3 divided by 8x plus 2 over x plus 2. Alright, I'm going to keep, change, flip one more time. 16x plus 4 over x minus 3 times x plus 2 over 8x minus 2. So I flipped this one and changed this to multiplication, just like we've been doing. Now I'm going to factor everything that I can, because nothing looks like it's going to cancel yet, so I do have to factor. On the top, I have 4 times 4x plus 1. Then I have that times my x plus 2. I'm going to kind of combine all this into 1. On the bottom, I have x minus 3, and then I can actually take out a 2. For that second one, I'm left with 4x minus 1. And let's see. Oh, I'm sorry, that's an 8x plus 2. 4x plus 1. Didn't see that. I was like, I know those are supposed to cancel. All right. Sorry about that. Let's see if any will cancel. Yes. 4x plus 1, 4x plus 1. X minus 3x plus 2 are not even remotely close to the same thing. And then 4 over 2 will reduce to 2 over 1. So I have 2 times x plus 2 on the top, and then on the bottom I'm left with my lonely x minus 3. Okay, and that is it. That's as simple as I can make it, the farthest I can go. All right, and kind of a long lesson here, but that's kind of like the meat and potatoes of this unit. We're getting into the simplifying and factoring and multiplication and division and everything like that. So large lesson, but very important. So yeah, if you have any questions, ask your teacher.